Welcome back, everyone. My name is Jake Lautensock. I'm a teaching assistant at Brigham Young University for Chem 285. This video, we're going to go over a few practice problems that help us develop some skills with IUPAC naming. Okay, here I have 4 examples, and I do have our functional group sheet to reference and some of the rules that I've written out here. So these problems are meant to illustrate a few common errors, and they actually end up kind of being some of the harder ones you have to name. Okay, I just made up these problems, so you'll see things similar to this, identical to it. Okay, so let's go ahead and begin with this one. So we follow the rules that we established in the part 1 video. The first thing we want to do is identify our highest priority functional group. In this case, our highest priority functional group is an amine. Okay, so if our amine is our highest priority functional group, we go ahead and look at our category amine, and under the suffix category, the suffix is going to be amine. If you remember, it is not one of these top 4. Therefore, you have to label where it is, the location of it, because it's not chain terminating like the top 4 are. So for example, this amine, if you were to redraw it, could be on this top carbon here, or it could be on down here. And again, those 2 are the same, but I'm just showing you the fact that it's not limited to just be on the 1 carbon. Okay, so it's going to be on the 2. You might ask, well, no, I thought it was the 1 carbon, 1, 2, and we have a methyl group coming off of here, right? Well, in fact, oops. Let's go back into this. Actually, what we have here we have the longest carbon chain, and we're just following our rules like we would on another molecule. We have to identify the longest carbon chain, and in fact, it's 1, 2, 3 carbons long, meaning that my amine is coming off of the 2 carbon. So what is 3? Well, 3 is prop, and we're going to ask ourselves, are there any double bonds in that longest carbon chain? The answer is no, so propan. And then we state where our highest priority functional group and what the highest priority functional group is. So propan to amine. Fun fact about this one, you can bring the 2 to the front of the word if there's no other substituents or other numbers. So we can do 2 propan amine. And that 2 is telling you that your highest priority functional group in amine is on the 2 carbon. Okay, so the answer to that one is propan 2-amine or 2-propanamine. Okay, moving on, let's look at this guy here. Make that double bond a little better. Well, what's my highest priority functional group? Well, the highest priority functional group is an alcohol. And if we look at our sheet here, if we find alcohol and go over, we learn that the suffix is OL. And again, this is not a chain terminating functional group, so we have to label where it is. So it's OL, and it is on, some might say it's on the 1 carbon, 1, 2, 3, with a methyl group coming off of the 1. But like we just learned in the last problem, you have to include the longest chain, which is going to include this one, 1, 2, 3, 4, and that highest priority functional group is coming off of the 2 carbon. Why wouldn't you have named it in this direction? Well, that would put that as a 3, and if we can give it a 2, we should. Well, what's the longest carbon chain? Well, it's 4, which is bute. Are there any double bonds in the molecule? Yes, it's on the 2 carbon, 2 to 3. So 2-ene, 2-ol. Bute 2-ene 2-ol. That's the name of that one. Okay, let's move on to this guy down here. Let's identify our highest priority functional group. So the highest priority functional group is an amide. And the easy part about amides is that the suffix for amide is just amide. Okay. The reason why I'm using this problem as an example in this video is because some students or some people like to look at this guy and say, oh, we have an amine on the 1 carbon, an amine on the 3rd carbon, and amine on the 5th carbon, and this guy is a ketone. So that my highest priority function group would be ketone. Well, you need to establish the fact that this is an amide, not an amine. Okay. What's my longest carbon chain? Well, it's 1, 2, 3, 4, 5, 6. And please ignore those red dots that keep appearing. They just disappeared, but I think they're indicating I'm spelling something wrong. So my longest carbon chain that's connected to the carbonyl carbon on my highest priority functional group is 6. So that would be hex. You're next going to ask yourself, is there any double bonds in my longest carbon chain? And yeah, we have one from the 3 to 4 carbon, so 3-ene. And then you'll throw in your functional group. And remember, an amide is chain terminating, so it has to be on the 1 carbon. So we don't have to label where it is. Okay. Well, what else do we have that we haven't named? Well, we have 2 amines. Okay, let's move this down a bit so I can write above it. And we'll group those together here. So we have 1 on the 3 carbon, a 2nd on the 5th carbon. How many total do we have? We have 2 of them. And what are they? Well, they're amines, and the prefix for an amine is amino. So 3,5-diamino. So we'll move this down. So 3, 5, 3,5 diamino. And you might ask why we have to, it's just very repetitive with all of this. So we have to state what the functional group is, how many we have of them, if it's 2 or more, and where each of them are. So one's on the 3 carbon, one's on the 5 carbon. And in this, you might say like, oh, just by looking at 3, 5, I must infer that there's 2. IUPAC naming is very thorough. It's going to want you to include the di. So 3, 5, diamino, hex-3-ene amide. Okay. Let's move on to this guy here. So again, what's my highest priority functional group? Well, it is carboxylic acid on the 1 carbon, so 1-oic acid. You might ask why I'm putting this 1 here if I know it's chain terminating. It helps me get into the habit of always telling or putting down on paper where the highest priority functional group is, because like we learned up here, that highest priority functional group doesn't always have to be on the 1 carbon. So it just gives me good habits when I look at problems like the first 2 we did. Next, I want to do is identify my my longest carbon chain connected to my highest priority functional group. Okay, so I'll do a quick pause in the video here. The next couple seconds are going to be wrong because I want to illustrate something that some students do. So some students, I'll do it in the erasing. So some students say 1, 2, 3, 4, while this is an ethyl group coming off of the 3 carbon, ethyl being 1, 2 carbons in length, okay? Well, why is this wrong? Think about it quickly. Well, that quote unquote substituent coming off it, as we named it here, actually changes the length of the longest carbon chain. So if we 1, 2, 3, and instead of labeling 4 here, we'll do 4, 5. That means our longest carbon chain is actually 5, which is pent. And this guy here is a 3-methyl, okay? So we have our root as pent. Are there double bonds? Yep, it's on the 2 to the 3 carbon, so 2-ene, oic acid. And then we'll 3-methyl. 3-methyl pent-2-ene oleic acid. Okay. If you have any questions about those, please feel free to reach out. Okay. Next, and I hopefully that kind of covers some of the challenging naming things that you will see in this class. We practiced here naming highest priority functional groups that are on the one carbon, and then naming multiple of the same substituents with an amide that kind of looks like our substituents. And we also practiced naming a molecule that kind of bends in a way that might not make it obvious what the longest carbon chain is. Okay. Now, so I want you to spend 75% of your time studying on looking at a molecule and naming it. The other 25%, I want you to practice looking at a name and drawing it. Okay. You do it in the same exact way that you do naming for looking at a molecule and writing the name, but you're going to flip the first step. And this is just how I do it. You are going to look at the root. So we'll start with the 2-butanol. And you want to look at the root first and draw it. This will give you like a skeleton backbone of the molecule, and all of your other pieces and highest priority functional groups and substituents can come off of it. Okay. So what's bute? Bute is 4. So 1, 2, 3, 4. 4 carbons in length. Our highest priority functional group is an alcohol. And where is that alcohol located? Well, 2 carbon. And what's my 2 carbon? 1, 2, 3, 4. Well, can't I name the other direction? 1, 2, 3, 4. And yeah, it's symmetrical, right? So it doesn't necessarily matter where you put it, but we'll just call that my 2 carbon there. Okay. So that'd be 2-butanol. Okay, let's fix this here. 4-amino. Whoops. 4-amino 3-hydroxy hexanoic acid. Looking at this name as an early on chemistry student, I might freak out and say I have no idea what that molecule looks like. I promise you, if you practice 75% of your time with naming molecules, this pattern of going from name to drawing it is very easy. First thing you're gonna do is look at the root, hexan. Hex is 6, so 1, 2, 3, 4, 5, 6. And my highest priority functional group is a carboxylic acid. And remember, it's a chain terminating functional group, so it must be on the 1 carbon. And quick note here, as you draw this extra piece in this OH group on the carboxylic acid, some students might be like, well, that changes my longest carbon chain because I drew a line off of that carbon. No, that's just simply a bond from this carbon 1 to an oxygen, right? So you didn't change this hex or 6 carbon chain at all. Okay. 1, 2, 3, 4, 5, 6. And then we'll just piece out the substituents onto it. So 3-hydroxy and 4-amino. So on the 4 carbon, we have an amine coming off of it, and NH2. And then on the 3 carbon, we have a hydroxy group, which is an alcohol. Okay, that is what I drew: 4-amino, 3-hydroxy, hexanoic acid. Okay, let's move on to this one. 2,2-dimethyl cyclohex-3-enone. So what's my root? Well, now we've included a cyclo. So remember that's part of your root. So let's draw that. So hex is 6, and there's a double bond on the 3rd carbon there, and it's going to be a ring because of cyclo. So 1, 2, 3, 4, 5. That last one there. So let's check that. 1, 2, 3, 4, 5, 6 carbons. Great. My highest priority functional group is a ketone. Remember, ketones are not chain terminating, so they can exist on any of the carbons. When they are in a ring, we like to put them on the 1 carbon. So you can literally put this ketone wherever you want. But that becomes your 1 carbon, okay? So we'll just put it up top like this. It's a little easier. And then we then place everything else. So on the 3 carbon, you can number either way, 1, 2, 3 that way, or 1, 2, 3 this way. You have a little bit of artistic liberty to draw it how you want. Okay, I'll go to the right. It's generally how we see it. So 1, 2, 3. We have the double bond there, which we did, and then we have 2 methyl groups. Where are those 2 methyl groups? Well, one of them's on the 2 carbon, and the second one's also on the 2 carbon. Perfect. So that would be 2,2. 2,2-dimethyl cyclohexylenone. And let's move on to this guy here. So what is my root? Well, my root is octan, no cyclo, so it's a straight chain. 1, 2, 3, 4, 5, 6, 7, 8. My highest priority functional group is an ester. That should, like, light bulb going off in my head that I'm going to have a special naming piece that I need to remember. So let's draw on my ester here. Remember, I'm not drawing an extra carbon. That's just a bond to oxygen. And that is when I need this guy. That's telling me how many carbons are coming off of that ester oxygen. Bute is 4. 1, 2, 3, 4. And let's check that. 1, 2, 3, 4. 4 carbons coming off of that ester. Okay, so then all we have left is to add in our substituents. So on the 3 carbon and the 4 carbon, we have 2 ethyl groups. And where are they? One's on the 3 carbon, one's on the 4 carbon. 1, 2, 3, 4, 5, 6, 7, 8. Do you need a number every time? No, I do it. It really helps me to make sure I'm putting them in the right spot. So an ethyl group, 1 F means 2, and YL means carbon chain. So on the 3 carbon, we have 2 carbons, and on the 4 carbon, we have that as well. And then we have on the 2 carbon an amine group, NH2. So that would be butyl, 2-amino, 3,4-diethyl octanoate. Great. Well, if you have any questions on naming or drawing from names, don't be afraid to reach out to one of your current TAs or myself, and we will be able to kind of assist you in more. Maybe you have a very specific question. Okay.